Good morning, guys. As we studied in previous lesson about the refraction of light, that when light travels in one medium and passes through the other medium, what happens? It changes its path. You can see we have a ray of light. This one is a ray of light, and its ray of light is passing through air into the glass slab. So you can see this glass slab is changing the path. Actual path was going straight, but now it changes a little bit and it is changing the path. So this process is called refraction. So here is a clear picture. The actual path of light was the above one, incident ray, but you can see the last one, the refracted ray, is the different one. So this is called refraction. Now to understand refraction further, we will study Snell's law. What is Snell's law? Snell's law tells us about the complete picture of refraction of light. For example, if you have this diagram, the light is coming from uh, in the air and it enters to the glass slab. You can see it changes its path. So the angle that is formed with the, you can say here, this is the angle. This is incident ray. This one, the first one. How can I show you? Where is it? The point is not here. I wanted to show you. Okay, so the first ray is incident ray. When it is from here, its actual path was this, but now it entered and it changed path, and change path is very important to understand. So this change path, now if you check the angles here, this is, for example, this one is the angle of incidence. I'm drawing, but it's not being drawn. How can I draw it? Oh, I can draw that here. Let me check from this one. If, for example, this is the angle of incidence, is it been written or not? Yeah. This is angle of incidence, and the actual path of ray was this. But now the ray is changing to this path. So this angle is refraction. If you look at clearly, angle of incidence is greater than angle of refraction. Are you agree with it? Yes, because yeah, it is bending toward. So if you see yesterday's lesson, glass has more refractive index. Refractive index of the glass is around 1.5, whereas refractive index of the air you studied is 1.000 something. So this means glass has more refractive index. So if light enters from a medium having less refractive index to more, it bends toward the normal, like in this condition. But if the same light is getting out from here till here, so you can say this one is normal. So this is the angle of refraction, it is greater. So you can say angle of incidence is less than angle of refraction when light is leaving the glass. So in this case, again, because it was in the glass, more refractive index, too less refractive index, so it will bend away. So this one is bent toward the normal, and this one is bent away from the normal. So whenever a light moving in a medium which is having less refractive index enters into high refractive index material, so light ray bend toward the normal. But if vice versa, that it is traveling in the denser medium, more refractive index, and get back to the rare medium that is having less refractive index, then it will bend away. So air to glass, it will bend toward, glass to air, it will bend away. So if Snell told us that if we take a ratio of sine of the angles, sine I over sine R, this ratio will be similar in both cases. If I have multiple, for example, refractive index N1 is for the air, let me say this is N1 and glass is N2 refractive index. So if I say N1 sine theta 1. Sine theta 1 is the incident angle here. So this product will always be same if I multiply n2 sine theta 2. What does it mean? It means that if I have refractive index n1 for the air and angle 1 for this one, so this product of n1 sine theta 1 will be the same as n2 sine theta 2. So n1 sine theta 1 is equal to n2 sine theta 2. So I can also say sine theta 1 over sine theta 2 will be equal to, or sine incident over sine refracted will be equal to n2 over n1. Or you can simply use this one as the refractive index or Snell's law. So here are three things. Number one, light traveling in one medium, get into another medium, will refract. Number two, it will refract toward the normal if it is getting into a denser medium which have high refractive index. Number three, the product of refractive index and sine of the angle in any medium will be the same. So he just said this one, that n into sine theta is equal to constant. So what does it mean? If I multiply n1 with theta 1 and n2 with theta 2, so with the sign of the theta 1 and theta 2, your answer will remain same. That's why he said n1 sine theta 1 in the air will be equal to n2 sine theta 2 in the glass, or n1 sine theta 1 in the glass, when it get back to the air, it will still be the same with n2 sine theta 2. So this is called Snell's law. This was told by the Snell. Okay, now, if this is the Snell's law, let me talk about the other thing. What is it? If we move uh, to the next slide, for example, here, there is a question. For example, I want to solve this one. This example, if you look at it in this example, this is this law that I wrote, that index of refraction n1, you can see here, this one. Index of refraction into sine of the angle is equal to index of refraction in the other medium with the sine. Now look at this diagram and look at the problem, that there is a ray of light that is entering from air to the glass. So angle of incidence is 60 degree, angle of refraction is 40.6 degree. If this is 60 and 40.6, what I will do? I need just to know the refractive index of the air, that is 1, and refractive index of the glass, that is, no, it's not glass, it's water, and 2 is 1.33. So you can see when we are doing this, we just simply said that n1 sine theta 1 is equal to n2 sine theta 2. I need this theta 2. If, for example, this angle they ask us to find, so what I will do, n1 sine theta 1 over n2, and then I take sine inverse and I got this answer here. For example, if I move to this one, they are saying what is the angle of refraction in case we found it. Where is the light beam entering diamond at 60 degree? So where the light beam enters diamond at 60 degree. The same question is, now they are using for the diamond. So for the diamond, N2, 2.42. So it is 2.42. Yes, please. 1.33 is for the water. Yes, it's given. Okay, now in this part B, what you have, I will write here n1 sine theta 1 is equal to n2 sine theta 2. But here in this case, they are saying what is the angle of refraction in case where the light beam enters the diamond. So if this one is not water, it is diamond. So what will happen? So n1 is how much for the air to diamond? So air is 1 into, no, for air it is 1, only 1.0. So sine theta 1 is 60 degree and 2, refractive index 2.42 into, they are saying find the angle theta 2. So sine 60 degree over 2.42 is equal to sine theta 2. So if I need theta 2, I will make sine on the other side, that will be sine inverse. So what will be the angle theta 2? Can you please check if you have calculator? So shift sine into sine 60 over 2.42. 20.96. I can approximate to 21. So 21 degree will be the theta 2. So this is all about the Snell's law. This will be given. This is refractive index of the diamond. Like water is 1.33, diamond is 2.42, glass is 1.5, air is 1. So we will just simply say. In the other case, light traveling is incident to the either ice or the glass with an angle 30 degrees. So the same question they are saying incident angle is 30 degree, and now light either enter to the ice. So it will enter to the ice or glass. So if it is glass, you will put 1.5 refractive index. So this question will be the same if you change the angle. So this 60 degree will change into 30 degree and 1.33 will change into 1.5. Can you please check? For the question number 4, if you have this one, sine inverse 1 over 1.5 into sine 30 degree. So what would be your answer? 19.4. So it is 19.5 degree. So this is theta. And if you have theta and you are asked to find refractive index, what you will do? Same thing, only this equation will change. If you want to find, for example, N2, so what you will do? N2 will be equal to N1 sine theta 1 over sine theta 2. That's it. So you can easily find. N is for refraction. N is for refraction, right? Yeah, N is refractive index. So this is all about Snell's law and refractive index. I don't think so it's hard. It's very simple. If you want